Thank you so much for coming out or staying here to come to my presentation. So welcome to JUnit 5. How many people here have used JUnit 5 already? Okay, a good amount of people. But to everyone else, they are also in the right location. We are going to be going through and learning about JUnit 5. As mentioned, my name is Billy Korando. I'm a developer advocate with IBM. You can find me at Billy Korando, and you can also email me at william.korando@ibm.com. I really do mean it. If you have any questions about this presentation, Java, Spring, or anything IBM Cloud related, definitely reach out to me and I will get back to you. I'm very happy to answer any questions you have. That's kind of why I got into developer advocacy. Also, the team I'm part of, the Global Java Developer Advocacy team at IBM, we also do a monthly Java newsletter. So if you kind of want to get an idea of what's going on in the world of Java, just consider subscribing to it. And also we have some great documentation on both Spring and Jakarta EE needs for doing cloud development. I'm just curious, how many people are Spring primarily here? About half. How many are like Jakarta EE or microprofile? A couple? Few? All right, cool. And also, if you leave with this presentation with an intense desire to know more, almost everything I cover in this presentation I've also covered in blog form on my blog covering JUnit 5. So definitely check that out because there are some pretty complex and interesting things in JUnit 5 that just won't have time to go super deep into, but it could be very useful for maybe some use cases. So definitely consider looking at it as well. We also had the recently released JUnit 5.6, and I should have a blog article out pretty soon that kind of just covers some of the new features and concepts that were introduced in JUnit 5.6 and other changes as well. So the goal of this presentation, I want to get you excited for automated testing. I'm guessing there is some general excitement given how many people have joined here. And then, of course, get you actually excited for JUnit 5 as well. If you're on JUnit 4, why should you consider moving to JUnit 5? When it comes to automated testing, one of the books that have had the most profound impact on how I view my role as a software developer was this book, Continuous Delivery by Jez Humble and David Farley. So I've been programming for about 12 years now, and I remember way back early on in my early career, getting into production was incredibly painful. I think we only did about 3 or 4 releases a year, not counting like emergency releases. And a lot of the reason behind that was because it was a very manual, difficult, painful process to get to production. And a lot of that was related to the fact that we were doing everything manually, particularly manual testing. And this kind of had some downstream effects in this production process. But with quality automated testing, you get really 2 big benefits. You get confidence that you're fixing what you're setting out to fix. So TDD, or at least writing some tests before you actually commit that are testing what you have changed. So you're pretty confident that, okay, yep, these tests so that what I actually set out to fix or change or add is actually working. And as you build up your automated test suite, you're going to be getting confidence then you're not going to be introducing a new bug. Particularly, again, remember early on in my career when heavily relying on automated testing, there was many times where I would make a change in one part of the application, but then there would be that side effect that would end up breaking something else unintentionally, and that was just a painful process, and that's also why it was so slow and difficult getting to production, because organizations didn't have much confidence in what they were pushing, so they would go through a huge amount of checklist to get to production. And it's also one of the things I kind of say that without automated testing, you're going to be building that legacy application that's eventually going to have to be rewritten at some point. You could be writing your program in the newest Spring Boot 2.5, whatever that's those current releases out there, using all the latest technology. But if you don't have a quality automated test suite that you can believe in, eventually you're going to just stop, or eventually you're going to have more and more complexity that gets added to that code, and you're not going to have that confidence to go back and refactor that code because you're not going to be sure what's going to change and potentially break something downstream. So you're just going to kind of live with this old, difficult to work with code because of the cost of changing it. And it's also a change that not in just the code that you write, but also those underlying dependencies. There's many organizations I've worked with before when I was working as a consultant before I became a developer advocate, where we were running dependencies that were many, many years out, months to years out of date. And again, that was related to the fact that we were heavily depending upon manual testing So upgrading even to like a patch dependency of an underlying dependency was a scary task because no one knew what would happen if we made that change. And the cost and manual labor hours of doing all that regression testing just wasn't seen as worth it. And that can lead, particularly when it comes to security, it's probably the most profound impact, because a lot of times when an organization gets exploited, it's not the first-party code that you're actually writing. They're actually looking for some problem in some underlying code. So, whatever version of like application server or Spring or your framework or whatever, they're going to look for an exploit there, and that's how they get broken into. I don't know if people heard much about the Equifax hack here in Sweden, but a company in the US that stores a lot of private information got hacked, and it was through a hack and an exploit in an Apache struts. But the real problem was they weren't keeping current of their Apache struts, because by the time that company was exploited, that had already been patched in Apache struts, but they were still so far behind, and it was probably because they were depending upon manual testing to do that, and they didn't want it up to upgrade. All right, so if you weren't considering automated testing or getting that in, hopefully that kind of got you more interested into it. So let's start talking about JUnit 5. What are some of the goals? Why wasn't JUnit 4 itself already good enough? So JUnit 4 came out in, I think, September of 2006 to 2007. It was, I think, around the same time that Java 1.6 came out. So, of course, the goal of any sort of major rewrite is to modernize. And when JUnit 5 came out in September of 2017, over that about 11-year period, one of the biggest changes in the world of Java was Java 8. And so JUnit 5 requires a Java 8 baseline. I'm hoping almost everyone's at least on Java 8 or later in this room. But Java 8 brought with it some major changes: lambdas, streams, and default method interfaces. And we're going to see how JUnit 5 takes advantage of those new language features. Another major goal of JUnit 5 was to improve the extensibility of the framework. JUnit 4, you could extend upon it, but it was somewhat difficult, and the API wasn't always consistent with it. And another big goal is that JUnit 5 didn't want to try to cover everything for all to testing needs. They wanted to provide a good foundation and then allow organizations or other libraries to kind of build upon it to test more specialized needs. Every organization, you're going to have like your own domain concerns. If you're like doing transactions or shipping or finance, you're going to have like certain domain concerns, and you can build upon JUnit 5 to kind of address those concerns within your organization, so to make it a little bit easier for testing. And we'll look a little bit at that in this presentation. But finally, if you already have a complex or advanced automated testing suite, maybe you're going to be really impressed by all the stuff you see in JUnit 5, but the most important thing is it has to be backwards compatible. If you already have hundreds or thousands or maybe even more tests at your organization, no matter how good JUnit 5 might be, you're not going to want to upgrade to that if it means having to rewrite all those tests or having like a very difficult migration process. So a major goal of the JUnit 5 team was to support JUnit 4 test and also all the way back to JUnit 3.8, if memory serves, and they really did a great job. We'll see a little bit of it here, but I've been following JUnit 5 pretty closely since it was released, and I've rarely seen any issues when it comes to backwards compatibility problems. So you should have a lot of confidence in upgrading to JUnit 5 that it's not going to break your existing automated test suite. By now, since we're a little over 2 years since the release of JUnit 5, this is getting to be less significant, but all the same, as I mentioned, Java 8 is the baseline, and the JUnit team has also been doing a good job about being compatible with whatever the current and even upcoming release of Java is. Any modern version of the major IDEs should work. Gradle 4.6 or later. For Surefire, the minimal version you want is 2.19, but you really want to be at least on 2.22. Otherwise, it's a really complex configuration work to get it working for JUnit 5. And I believe the most current version is 2.22.1 or 2, which also fixes a couple of small JUnit 5 issues. So really, as always, being on the latest version of whatever out there is really your best bet, but these are the minimum versions you need to start using JUnit 5. All right, so writing tests in Jupyter. One thing the JUnit team also did was made JUnit more modular, and it's broken up into 3 separate modules. There's Vintage, which is all the backwards compatibility support for JUnit 4 and JUnit 3.8 or later. Then there's the JUnit platform, and that provides like all the tooling support for both like Maven, Gradle, and the IDEs. And then there's Jupyter. As developers, we're primarily going to be working with Jupyter, and that's an actual new programming language framework of using JUnit 5. If you're wondering why it's called Jupyter, well, Jupyter is the 5th planet from the sun, and it also then just starts with JU, so that kind of worked out pretty well. So to start writing things in Jupyter, there are some language changes. So instead of using org.junit.test for your test annotation, you would use org.junit Jupyter API test, and that would then denote within the JUnit framework that this is a JUnit 5 test and to allow it to be able to use the JUnit 5 features. There is instead of using org.junit assert assertions, you would use org.junit Jupyter API assertions. Really, you could actually still use JUnit 4 assertions because really what the JUnit framework is looking for is the assertion exception, which is what org.junit assert would still throw. But there's a few new assertions that we'll look at in the Jupyter framework, which are also beneficial. Ignore has been replaced by disabled, and then disable is a lot more flexible, which we'll touch on a little bit later. Run with, rule, and class rule have been replaced by this new extensions model. And then before class and before, after class and after have been both changed with after all and before each, and this is a lot more clear. I remember plenty of times kind of being confused. I'm like, so is before everything, or before each class, or before each method? So it's a lot more clear when you have before all and before each and after all and after each, what the meaning of is in those terms and what those methods are trying to accomplish. So let's take a look at actually writing a JUnit 5 test. So here, I have a package, and these are all JUnit 4 tests here. Overall, I mean, it's only about like a dozen or so tests here, or maybe about 8 or 9. But there are doing some complex things. I have like a integration test here, and it's using test containers and a couple other things that are kind of just doing some different tests. And of course, because it's a live demo, something fails, but well, generally they should pass, and I think I remember there is like some small exception that's happened that it's not anything with JUnit 5, but some other underlying library that changed for me. But overall, generally, all your tests should pass without any issue. But let's take an existing class that was all written in JUnit 4. And is that text big enough for everyone even in back, or does it need to be bigger? Okay, good. Okay, cool. All right, so I'm going to take this and copy it down here. And so as I mentioned, instead of using org.junit test, we would use org.junit Jupyter API test, and then we would also be using the new org.junit Jupyter API test. So let me get those imported. So like I said, org.junit Jupyter API test. And you would want to use the assertions package instead of the assert package. That's the JUnit 5 one. So if I save those, that resolves most of the compilation errors except for this one. So in JUnit 4, if you were wanting to test for an exception that's going to be thrown from some code, typically you would have been doing this with the expected exception. But that's no longer supported in JUnit 5. Instead of doing that, we would use assert throws. And then we would say what the expected exception type is. In this case, this custom room service exception. And then we will use a lambda to actually execute the code that we're going to be testing. And then assert throws would then actually throw back an instance of the exception that we're checking for. So I can just do simply this. And so now this is much cleaner. Instead of having that try catch around there, now I can just do it. It's fewer lines of code. It's also not divided up. All of the stuff that I'm testing for is actually within the test case method itself, instead of actually being like partially up within the declaration of the test case, and then also within the test case itself. So that's a lot better. Now if I go ahead and run this stuff, let's see if everything executes correctly. All right, so I have 3 tests that executed properly, but then one that failed. So the one that failed was using a rule, the expected exception rule, which ironically I didn't really even know about until I started learning about JUnit 5. So expected exception is another way of trying to catch exceptions or test for exceptions in JUnit 5 that was a little bit cleaner, but all the same, as I mentioned, rules have been rolled in and deprecated into the new extensions model. But let's say you are dependent upon rules at your organization and you want to start taking advantage of JUnit 5, but don't want to completely abandon these rules yet because maybe you just have like a lot of backwards compatibility and work that's going on within them. So JUnit 5, the team, they've allowed that, and what you would do then is you would enable, or you would add the annotation, enable rule migration support, and to get access to this annotation, you would need to include the JUnit Jupyter migration support package dependency as well within your test. While I was saying we add that in, and we can run this test again. And now everything passes. All 4 of the tests passes. All right, so that's great. So, we're pretty much back to where we were before, and we do see at least some advantage because now we have the assert throws up here, which is a bit cleaner than it was before of using the assert throws. That's a bit cleaner than having to use the expected exception before in JUnit 4. But there are some advantages just to your typical test that JUnit 5 provides. One of them is, who's ever been in that scenario where you have multiple asserts here in a test and the test starts to fail, you go and you fix like the first assertion, you fix the test, and then that first assertion fails. Okay, you fix it, you run it again, that second one fails, the third and fourth. You have that constant loop, and it's just a very frustrating thing. So instead of having to run into that really frustrating scenario, what we can do is wrap all of this in assert all. And again, this is where we see the benefits of Java 8. We would then execute this with lambdas. There we go. And then let me go ahead and then make it so all these will fail. And now you see here that when this fails, instead of just getting back that first exception or the first error because the ID field was wrong, we're getting back all four of the exception or assertion failures in the same test report. So that's really great for those instances where you're going to have multiple assertions within the same test. You can just wrap it all in that assert all, and you don't have to worry about getting into that scenario I was mentioning earlier of having that loop of having to fix it, break it, fix it again, and so on. But there's even more for kind of just your typical everyday test. So generally speaking, the parameters that are the constraints around what JUnit or Java allows for method names is pretty good. You know, we have test find by valid name room. You know, if you wanted to, you could also have like underscores in it. But maybe you're like, let's say you're doing more like feature-driven tests or something like that, where you maybe want to have like a longer explanation or something like that within your test name. You can now have display name. And now, if I was to run this, in the test report, we see instead of test find by validation or valid room type, we get a really cool test name as the name of the test that shows up in the test report. But that's not all. This is by far the most important feature that was added to JUnit. Now we can take passive aggressiveness and automated testing to a whole new level, and we can put emojis, specifically the poop emoji, within your test name, and you can just really tell what you really feel about an automated test. I will say, though, the JUnit 5 team did not spend a bunch of hours saying, how can we support emojis in our test? What would really happen is they wanted to support Unicode, so that can be very important for if you're not using just the standard kind of Latin characters to support that. And then with that Unicode support came emoji support. So that's really why we have emoji support in here, was support Unicode. All the same, there could still be some benefits if you're doing internationalization, which is really important here in Europe. You could maybe put the name or the flag of the country of the language you're translating to. That could be kind of helpful, saying like, okay, here, translating to Swedish, Norwegian, Finnish, which could be pretty helpful for someone who may not be super familiar with the differences in knowing, oh, okay, that's what's actually happening here. So there are some valid if-edge use cases for emoji support in JUnit 5. All right, so that's kind of like the typical everyday kind of stuff you're going to see from JUnit 5. Let's start kind of getting into some of the more advanced stuff that's coming with JUnit 5. So as I mentioned, rule, class rule, and run with have all been rolled into the new extensions model. And so there's multiple ways an extension can be declared within a class. You can have extend with, so that can be declared at both the class level and then also the individual method level to declare for an extension. You also have register extension, and that can be more programmatic and dynamic, so you can actually reference members and values within the class, and that can be declared on individual fields within a class. And then also you have the Java Service Loader. Who's here knows about or has used the Java Service Loader before? 3, 4, okay. It's usually about that number I see, you know, that ratio. If it's like remove 20 people, it's like one person, but we'll touch on that as well. But what are some of the advantages of the extension model? Again, why was there a change? Well, the biggest one is you can declare multiple extensions in a single class. I'm sure people have had that frustrating experience of only being able to use one run within a class and then being like, oh, why can't I do another one in here? You can have as many extensions as you want within a single class. You also have control over the execution order of extensions, which I'll get into a little bit towards the end of this presentation. But also importantly, you have a single API now for writing extensions instead of having the rule, class rule, and run with APIs all being a little bit different. So it's just one thing to learn, and then you can maybe more easily share and rework those extensions for other uses. but yes. I have a few extensions here, or a few examples of these extensions where I'm referencing values within it, and I go into more depth. I have a series I need to get back to you that where it really goes into depth of using the new extensions model in JUnit 5. Another significant improvement in JUnit 5 is dependency injection. So whereas within JUnit 4 and 3 that haven't really used a whole lot, you can only do passing values at the method level. So like if you're using like a lot of or Spring Boot, like you would annotate some fields with auto-wired within your test class. But now there's support for testing passing values in as constructor values or even directly into methods as method arguments. And there's also a few values always available. For example, there's test info, and that can be good for printing out diagnostic information about the test in a test container. That could be useful for debugging tests, like why is it failing? You may find out that maybe it's not running in the correct order or what you're kind of expecting. So there's a couple of things that's always available in it. And let's kind of just take a look at that. So here's an example, particularly with using Mockito. And to kind of enable that behavior specifically with Mockito, I do need to use the Mockito extension. But here, I'm passing in as a constructor value a mock implementation of this boring service. Also here, as I mentioned, is this test info. And then here, I'm also passing in this mock value as a test method or as a method argument. So here we can see in this example, I am using the class level of the boring service, whereas of course with going by Java, this is the more local version of it. So I'll be using this mock implementation of this, again, boring service. Let's just go ahead and give this a run. So here we can see some of the diagnostic info that's displayed that comes with test info. And again, that could be good for debugging needs if you're kind of wondering maybe why something's failing and it doesn't really make sense. And here, let's see. So here, I'm saying the Mockito extension to use return a value of 2, which of course then is tested here within this class, or within this test case, and then here I'm setting it to say 3, which is being tested here. So this is an example, particularly of being able to pass something in as a method level argument, of being able to kind of reuse and change, like mocking an underlying class between different test cases in a much more clean fashion than usually is what allowed. Another nice thing that can be that's enabled from this is when you're maybe mocking or just using underlying services, by passing it in as a method argument, you kind of are saying within that test case name or just a signature of it, like what's some of the underlying dependencies that's going on in this test case. And that could be kind of a useful thing from like an architectural perspective, like you can kind of understand the dependency graph and the relationships between your other parts of code kind of just from looking at the test report of an application, or the test report that's generated from an application when you're running the automated test suite. Okay, so parameterized test, repeated test, and dynamic test. Parameterized test, before we only had run with, and you can only have a single then test within a run with class. Now you have parameterized test, and you can have as many parameterized tests within that test class as you want, and you can even have this other normal test within that test class as well. So that's a really nice thing, because I've ran into one scenario one time where I was doing a parameterized test, but I also had a couple of other scenarios that were kind of outside what I could do with that parameterized test, and I had to put them in 2 separate class files. Now you can put them all in the same test class, and they can all run together. And there's many different ways of supplying values to parameterized tests. There's value source, method source, enum source, and CSV file source. So particularly if you're having like maybe like a really large data set, you can have like CSV and CSV file source to kind of really supply a huge amount of data. Also, when using method source, you can actually reference a method in a different class to that, so that way you can maybe separate your actual test case from like the test data that's actually being run. And let's see if so here's an example of that. Also with test method source, by default, it will look for a method with the same name as the method of your test to pass that in. So if you have that, this will run. So that runs 4 times, as we can see here. If it's a different name, you simply just need to put the name of the method that you're going to be referencing for that method source. And if it's external, you would put the fully qualified name of the test. So if you're, in this case, it wouldn't be external, but this would be the syntax of referencing an external method. You put the fully qualified name, #, and then the name of the method that will be supplying the data. So that can, again, be a good way of separating the actual test that's happening from like maybe all the data, which could be useful if you have a lot of data. Repeated test. So if for some reason you have a test case that you need us to execute a bunch of different times, you can just throw repeated on there, say how many repetitions you want. You can customize the name. Also within that, so I mentioned there's like test info available in the application context. Within a repeated test, there's repetition info, and that's going to have like the current iteration and the total number of iterations. So like maybe you want to insert a bunch of records within a database, you can get like the repetition ID and just continually pass that in to maybe as like the dynamic value to put into those tests. Like I said, edge case, but you know, if they ever need this to run a test a bunch of times, that can be very helpful. Lastly, there's dynamic test. So this actually took me a really long time to get my head around. With the dynamic test, you would actually be describing the kind, like what the test is going to look like instead of actually writing out the test itself. And so where I have found this useful was with a cross-cutting concern. And to give like a concrete example of this, let's imagine I am building out a RESTful API, and this RESTful API is going to have 2 different kinds of clients. Clients that are only going to be accepting JSON, and another client that's only going to be accepting or sending XML. Something like that, as like you build out that API, it can be really easy for a developer to forget to maybe add like the accepted media type of XML or JSON or something like that, and it wouldn't be easy to see that someone missed to add that. So you can use something like this, a cross-cutting concern with like test accepted media types, where it's a bunch of complex code, but pretty much what I'm saying it to do is to scan my class path to see if there's any references to post endpoints, and then to write a test around that, passing in a bunch of just random XML or JSON data. So if I run this test, here we'll see I get 2 returns back, or 2 test method executions, making sure that, again, post endpoint can accept both JSON and XML data. If I go back into my code, and if I just simply uncomment this endpoint and then run the test again, now I get 4 executes, or I get 4 test runs, and then one of them failed because here I did exactly what I was talking about. I forgot to put both JSON and XML as an accepted media type. So dynamic tests, again, you're probably not going to use them a whole lot, but they can be really useful for cross-cutting concerns. Like another example could be like security. Maybe for like all your get endpoints, you just need to have like a certain security rule, but for post endpoints, you would have to have like an admin rule. dynamic tests could be a great way of writing those tests out just to make sure that all your endpoints are following that kind of that kind of security practices. Test interfaces. Again, test interfaces was something that took me a little bit of a while to get my head around and also to find a use case. So as mentioned, in JUnit 8, we were able to now declare default method interfaces in test. And where this can be useful is that in JUnit 4, you could do something similar with using abstract classes. But of course, in Java, you only have single inheritance, but Java also allows you to implement multiple method interfaces. So test interfaces could be really great for making testing some kind of like pattern easier. And it's particularly useful when that pattern where a developer or an application may only be implementing parts of that pattern. And it's also good for making sure that people are following that pattern guidelines. So the example I put together of this is maybe like writing a RESTful API. So testing a RESTful API can be kind of difficult. Also, REST has a very specific pattern, but also not every RESTful API is going to implement every single part of the RESTful API. You may only be doing get endpoints for a controller, maybe get, post, and put, and so on. You're not necessarily going to implement get, post, put, delete, heads, options, all that on every single controller because it's not always going to be necessary. So yeah, here's like maybe an example of a RESTful API, and then also the kind of patterns. Again, if you're following the proper RESTful stack, it should be, resources, whatever concept that you're going to be referencing at the end of it. And if you're going to be getting a specific item of it, you should be referencing that ID. And there shouldn't be any verbs within it because the verbs are in the HTTP method itself, the get, post, and put. Again, not necessarily need to follow this RESTful API, just using this as an example because it's pretty widely known. So then what you can do is write a interface, and in this case, I'm going to be saying like, okay, here's how we're supposed to be testing gets for an endpoint, and then I'm writing out the default test, and then for that default test, it is a bit complex and dense to look at, but pretty much I'm making sure people are following the RESTful API specification to test it and then to call to that. So yeah, here's an example of like getting a specific existing resource, getting all resources, getting something that doesn't exist. And like, for example, the thing that doesn't exist, I want to make sure that if the person gets a non-existing thing, a 404 is returned versus some other kind of HTTP code. And so yeah, if RESTful API implements get, they can just do just like the get endpoint. If they're implementing post, then I have like a specific like post test interface. If they're implementing like everything, they can do get, post, search, so on. All those, you can kind of divide up this patterns into these maybe separate discrete things. Here I'm using REST as an example, but like another example could be doing like database work. Not every application, maybe you're doing CQRS. So maybe some applications will only be doing reads, while other ones will only be doing updates, reads, and deletes as well. So you can kind of use test interfaces to break up common patterns into discrete areas, and then again, it can help encourage making sure developers follow a pattern, and then also make it a little bit easier to do some testing as well. Disabling the filtering. So this is particularly with disabling an area that JUnit 5 is significantly better than JUnit 4. So as I mentioned, ignore has been replaced by disabled. And now, whereas in JUnit 4, you could only do ignore tests and then it would be skipped all the time. Now you can add some logic to where tests would be disabled based upon certain conditions. You can do this by completely custom logic. You can implement your own kind of disabling condition, but the JUnit 5 team has also provided several of their own pre-supplied conditions. For example, operating system version, JDK version, and actually in JUnit 5.6, they've added the ability to disable based on Java JRE range. And again, they also offer custom logic. also somewhat related to this, there was the enable if and disabled if, but that has actually been removed in Java 5.6. So if you've been using that, you will need to migrate away from it if you're going to use JUnit 5.6. But just like ignore, disabled will show up as skipped within the test report. Filtering tests, so this is like, I believe it's called, was categories in JUnit 4, but tests can be tagged with @tag or tags, and you can just put arbitrary strings within that to then just say when tests to be filtered or not filtered. But unlike ignore tests, filter tests do not show up in the test report. So if you're doing an exclude or include, whatever it might be, and you have like 100 tests and you're excluding and including by 50, then only 50 will show up as in your test report. It won't make any reference to the 50 non-executed tests. So something to keep in mind when doing that. Parallel test execution. JUnit 5 offers a lot of flexibility with that. So within your build file, you can kind of provide some configuration for how tests should be executed in parallel. Of course, the first parameter is just enabling it at all. The second one, config dynamic factor of 1. So a dynamic means it's going to reference how many CPUs are on the system that you're running. In this case, my Mac, it's 4 CPUs. And a dynamic factor of 1 means 1 thread for every CPU on your system. There's also static, where you can say, I only want 2 threads ever executing at the same time. So there's some options there on how many threads or how many tests you want executing at the same time. There's also concurrent, and then there's also serial. And so concurrent would be, you can have like 2 tests, you can have multiple test cases executing concurrently within the same test class. Serial would mean every test class would have its own thread, but you could have multiple tests executing simultaneously. So you have some flexibility there. And so that's at the global level, but let's say there's individual test classes or test cases where you want to have something kind of changed up. You can put the execution on that to say, okay, for tests in this test method, we can actually have test cases executed concurrently, whereas for, sorry, it was also same thread, not serial, but in this other test, we want all these test cases executed within a single thread, but maybe it could be executed at the same time as another test class. You can also have things that have a resource lock. So that value is just, again, an arbitrary string, but then you also have the mode of read-write. So those first 2 tests, because they're read-write, they will never be executed at the same time because you could be manipulating underlying state. These bottom 2 tests, because they're both read, they could be executed at the same time, but they won't be executed at the same time as the read-write methods, because again, this could be changing the underlying state to that, but there's no guarantee in the order. So these read tests could be executed either before or after the read-write test in that. So it's just something to keep in mind, but again, there's some of that flexibility that's provided when writing parallel tests. Now, if you do need guarantee on execution order, there is the ability to order test and even extension execution. The most common way this will probably be consumed is with the method order and the order annotation, and you can explicitly declare the order your tests can be executed in. Something that's new in JUnit 5.6, in 5.5 and before, these bottom 2 tests would be executed at the very end of the test case because they didn't have an order, but now instead, tests that don't have an explicit order, they have their default value then is max integer max value divided by 2. So now these tests, if in JUnit 5, they would still have been executed before these 2 unordered tests, but now you can have it set up to where you can have kind of guarantee that certain tests will be executed at the very end of a test class, whereas before that wasn't really possible. So by setting these to max value, they will be executed last and second to last. As we can see, first, second, second to last, and last. Also, same rules apply when doing ordering for registered method extensions. So order 1, order 2, you do not need to add this test method order execution. That's only for ordering the actual test cases. By putting order 1 and order 2, then those two extensions are executed first. When declaring it with like extend with, the order within the class file that those are declared is the order of the execution for those extensions. But that's not all. We covered a lot pretty quickly here in JUnit 5, but there's still a good amount more. If you're using a assertion framework like AssertJ or Hamcrest, you can continue using that in JUnit 5 without any issue whatsoever, but you work perfectly fine. There's also things like nested tests, assumptions, console launcher. They're continuing to add even more in the newer versions of JUnit 5. The documentation really is excellent. A lot of this presentation, this is me reading the documentation and then putting it into presentation format. So if you have more questions or you really want to get more in depth on something, definitely check out the documentation. Like I said, it's really pretty excellent overall. If you have any questions, please ask them now. Also, you can find the slides at that link, and then also I have a lot of code examples, like I was showing earlier, at this JUnit Welcome to JUnit 5 version 2. So definitely check those out. So I think we have a few minutes for questions. Yes.
What about time test and load test?
Time test. I can't remember if there was a timer test on it. Load test. That's, again, an area where JUnit 5 isn't necessarily trying to do load testing. There might be extensions available to kind of better handle load testing, but that's not something, like you can maybe kind of with an extension kind of do some load testing, but that's not like a major goal within the JUnit 5 framework. Yes?
Testing asynchronous code.
Yes.
Is that something
I'm sure they have that. I haven't really worked with that, so I can't give you like a really good example on that. Any other questions or? Okay, great. So thank you so much. Thank you so much for coming out. And again, if you have any questions, send me a DM or send me an email. I'll be happy to answer them. Thank you.